Hello, in this lecture we will find out the diameter of the orange circle. In the drawing we have three semicircles and one circle that is inside the big semicircle, and we want to find out the diameter of this orange circle. So first of all we will define the centers of the semicircles. We have already know that the center of the orange circle is at this point C. So we will define the center of this semicircle. Actually, the diameter of this semicircle is given us and it equals to 10 inches. So we'll define the center of this semicircle as point X. We know that the big semicircle, the diameter of the big semicircle is equal to 10 plus 20. The diameter equals to 30 inches. Therefore, the radius will be equal to 15 inches. And the center of the big semicircle is at this point. So we'll define this center as Y. And we define the center of this semicircle that its diameter is equal to 20 inches as Z. In the next step, we will connect between the center of the orange circle that is at point C and the centers of the other semicircles. Okay. And I will present to you a new rule that is actually connected to the connection between two circles. Actually, two circles can touch each other in two different ways. The first type of tangency is when the two circles are touching each other externally, like in this drawing. Here we know that the center of this circle is at point O, and the radius of this circle is equal to capital R. We know that the center of this circle is at point M, and the radius of this circle is equal to small r. Then actually the distance between the centers and the two circles are touching each other externally at this point. This is the point of tendency. Then whenever two circles are touching each other externally, we are talking about external lunge or external tangency, and the distance between the centers of the two circles will be equal to MO. It is the length of line segment MO, and it will be equal to the sum of the lengths of the radii. That is to say, OM or MO equals to capital R plus small r. I will repeat again, whenever you have an external lunge between two circles, that is to say, they are touching each other externally, like in this drawing, the two circles are touching each other externally at this point. This is the point of tendency. Then the distance between their centers, that is to say MO, will be equal to the sum of the lengths of their radii. That is to say, it will be equal to small r plus capital R. And we also have a second type of tangency between two circles. The second type of tendency is the internal lunge or internal tendency. In this case, the two circles are touching each other internally. At this point, this is the point of tendency. And then the distance between the centers of the two circles that have an internal lunge between them, that is to say, the length of line segment OM, will be equal to the difference between the lengths of their radii. In this case, it will be equal to capital R minus small r. OM equals to capital R minus small r. Okay, I'll repeat again. Whenever you have an external lunge between two circles, then the distance between the centers will be equal to the sum of the lengths of their radii. That is to say, in this case, it will be equal to capital R plus small r. While if the two circles have an internal lunge between them, like in this drawing, then the distance between their centers will be equal to the difference between the lengths of the radii. In this case, it will be equal to capital R minus small r. So according to this rule, we'll calculate the distance between the center of the orange circle that is located at point C and the centers of other semicircles that are located at point X, Y, and Z. So what is the distance of CX between the centers of the orange circle and the center of this semicircle? That is actually CX. Here CX will be equal, we will define the radius of the orange circle as R, small r, and those, the semicircle and the orange circle, have an external lunge between them. Therefore, the distance between their centers will be equal to the sum of the lengths of their radii. So here, the radius of the orange circle equals to R, and the radius of this semicircle is equals to the diameter over 2. That is to say, it equals to 10 inch over 2, that is 5. So 5 plus R is the distance between points X and C. So XC will be equal to 5 plus R. XC or CX will be equal to 5 plus R. I'll repeat again, this orange circle and this circle have an external lunge between them, and whenever you have two circles with an external lunge between them, then the distance between their centers, in this case CX, will be equal to the sum of the lengths of their radii. That is to say, the radius of the semicircle is 5, and the radius of the orange circle is r, and the sum of the lengths of the RDI is pi plus r. Likewise, we calculate the value of Cy, the distance between the center of the orange circle that is located at point C, and the distance between the center of the biggest semicircle that is located at point Y. Here we know that the radius, actually the orange circle and the biggest semicircle have an internal notch between them. They are touching each other at this point, and therefore the distance between their centers will be equal to the difference between the lengths of the radii. So, and the radius of the biggest circle is equal to 15 units, while the radius of the orange circle is equal to r. So in conclusion, we found out that the distance between the center of the orange circle and the center of the biggest semicircle is 15 minus r units. Okay. And what is the distance between the center of the orange circle and the center of this semicircle? That is to say, line segment CZ. Here, those two circles, the orange circle and this semicircle, have an external notch between them at this point. They are touching each other externally at this point, and therefore the distance between their centers, that is to say, the length of line segment CZ, will be equal to the sum of the lengths of the radii. And the radius of this semicircle equals to 20 over 2, that is 10 units, and the radius of the orange circle equals to 5. So in conclusion, CZ will be equal to 10 plus 5. 10 plus r. I repeat again, the radius of this semicircle is 20 over 2, is 10 units, and the radius of the orange circle equals to r, and the distance between the centers of two circles that have an external notch between them will be equal to the sum of the lengths of their radii, that is to say, it will be equal to 10 plus r. Okay? And what is the distance between xy, the length of xy, that is the distance between this semicircle and this semicircle? They have an external notch between them at point P. Therefore, it will be equal to actually xy is the distance between the center of this circle, that is radius is equal to 5 units, and the distance between the biggest circle. So those two circles have an internal length between them at point A. Therefore, the distance will be equal to the difference between the lengths of the radii. And the radius of the biggest semicircle is 15 units. The radius of this small semicircle is 5 units. So 15 minus 5, it will be equal to 10 units. So if we know that xy equals to 10 units, and what is the length of xz. xz, at point x we have the center of the small semicircle. At point z we have the center of this semicircle, that its radius is equal to 10 units. And here we have at point x the center of the small semicircle, that its radius is 5 units. So, and whenever you have two circles with an external amount between them, then the distance between their centers, in this case it is xz, will be equal to the sum of the lengths of the radii. The radius of the small semicircle is 5 units. The radius of this semicircle is 10 units, and 5 plus 10 is 15. So we found out that xz equals to 15 units. Okay. In the next step, we will focus on triangle CXY, and we will implement the law of cosines on triangle CXY. So, what is the law of cosines? The law of cosines is true for any triangle. You can implement the law of cosines in any triangle. According to the law of cosines, if we have triangle ABC, that could be any triangle, this is triangle ABC. We know that side AB of triangle ABC equals to A units in its length, side BC of triangle ABC equals to B units in its length, and side AC equals to C units in its length. And we also know that the angle between side AB and side BC is theta. Then, according to the law of cosines, here C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. I'll repeat again, the law of cosines is true in any triangle. So we will implement the law of cosines in triangle CXY. So I will draw triangle CXY in a new page, and we will implement the law of cosines in this triangle, triangle CXY. This is triangle CXY. And we'll define this angle as angle theta. The angle between side CX and side XY defined as angle theta. We'll implement the law of cosines in this triangle, triangle CXY. According to the law of cosines, here cy square. This will be equation number 1. Cy square. But first of all, we have already found out that cy equals to 15 minus r. xy is equal to 10 units. And cx equals to 5 plus r. So we implement the law of cosines in this triangle cxy. So here cy square must be equal to cx square plus xy square minus 2 times cx times xy cosine theta. Okay, according to the law of cosines, cy square must be equal to cx square plus xy square minus 2 times cx times xy times cosine theta. We know that cy is equal to 15 minus r, so we substitute cy by 15 minus r. So cy square will be equal to 15 minus r square. That equals to cx squared. Cx is 5 plus r, so cx squared will be equal to 5 plus r square plus xy square. Xy equals to 10, so xy square is 10 squared, that is 100, minus 2 times cx is 5 plus r, and xy is 10 times cosine theta. So here we will open the brackets on both sides of equation number 1, and we'll get that according to equation number 1, (15 minus r square equals to 15 square, that is 225, plus r square minus 2 times 15 times r, that is actually minus 15r, that equals to 5 plus r square. 5 plus r square equals to 5 squared, that is 25, plus r square plus 10r plus 100, 2 times 10 is 20, so it is minus 20, 5 plus r cosine theta. So here, in this side of the equation we have 225, and the other side of the equation we have 125. So we subtract 125 from this equation, and we also cancel r square. We have r square on both sides of the equation. So 225 minus 125 is 100. 100 minus 30r equals to 10r minus 25, 5 plus r times cosine theta. We subtract 10r from this equation, and we get here 100 minus 40r equals to minus 20, 5 plus r times cosine theta. So here we'll divide equation number 1 by minus 20 times 5 plus r, and we'll get that according to equation number 1, 100 minus 40r over minus 25 plus r equals to cosine theta. Here we will divide both the numerator and the denominator of this equation, on this side of equation number 1, by minus 10, or we divide it by minus 20, and we'll get that minus 40r over minus 20 is 2r, 100 over minus 20 is minus 5, over minus 20 over minus 20 is 1, so it is 5 plus r. So in conclusion, according to equation number 1, cosine theta equals to 2r minus 5 over 5 plus r. This will be equation number 1. In the next step, we will implement the Pythagoras theorem on triangle CXZ. So I will copy triangle CXZ in this new page, and we'll implement the law of cosines in triangle CXZ. We know that Cx equals to 5 plus r. Xz, we have already found out that Xz equals to 15 units. And Cz is equal to 10 plus r. This is angle theta. So here, equation number 2 will be Cz square, according to the law of cosines, Cz square must be equal to Cx square plus Xz square minus 2 times Cx times Xz cosine theta. Here Cx equals to Cz equals to 15, so Cz square is 15 square. 15 square is 225. That equals to Cx square. Cx is 5 plus r, so Cx square is 5 plus r square plus Xz square. Actually, here Cz is equal to 10 plus r, so Cz square will be equal to 10 plus r square. Here we have 10 plus r square plus Xz square. Xz is equal to 15, so Xz square will be equal to 15 squared, it is 225, minus 2 times cx, that is 5 plus r, times xz, that is 15, cosine theta. So according to equation number 2, we found out that plus r squared is here 10 plus r squared. In this side of the equation we have 10 plus r squared is equal to 10 squared, that is 100, plus r squared plus 20r, that equals to 5 plus r squared. 5 plus r squared equals to 25 plus r squared plus 10r plus 225. We have minus 2 times 15 is minus 30. 5 plus r cosine theta. So here we have 100, and here we have, in this side of the equation, we have 225 plus 25 is 250, and here we have 100, so we'll subtract from equation number 2 100, and here 250 minus 100 is 150. Here we have r squared on both sides of the equation, so r squared will get cancelled. And we have here 10r, and here we have 20r, so we subtract 10r from this equation, equation number 2, and here we will have 20r minus 10r is 10r. So we got in conclusion that 10r equals to 150 minus 30 times 5 plus r cosine theta. So here we will add to this equation 30 times 5 plus r cosine theta, and we get that 30 times 5 plus r cosine theta equals to 150 minus 10r. Here we'll divide this equation by 50 times 5 plus r, and we will get that according to equation number 2, cosine theta equals to 150 minus 10r over 30 times 5 plus r. Here we divide both the numerator and the denominator on this side of equation number 2 by 10, and we get that according to equation number 2, cosine theta is equal to 150 over 10 is 15, minus 10r over 10 is minus r, over 30 over 10 is 3. So in conclusion, we found out that according to equation number 2, cosine theta equals to 15 minus r over 3 times 5 plus r. In the next step, we will create equation number 3, that states that cosine theta according to equation number 1 must be equal to cosine theta according to equation number 2. So here, equation number 3 states that cosine theta according to equation number 1, that is equal to 2r minus 5 over 5 plus r, must be equal to cosine theta according to equation number 2, that is actually equals to 15 minus r over 3 times 5 plus r. Here we will multiply equation number 3 by 5 plus r. So 5 plus r, it gets cancelled. And we have 2r minus 5 is equal to 15r, 15 minus r over 3. Here we will multiply equation number 3 by 3, and we will get that according to equation number 3, 3 times 2r minus 5 equals to 15 minus r. We will open the brackets on this side of equation number 3, and we will get that 3 times 2r is 6r. 3 times minus 5 is minus 15. It equals to 15 minus r. Here we will add r to this equation number 3, and we will add r, and we will add also 15 to this equation number 3. And in conclusion, we get that 7r equals to 30. We divide equation number 3 by 7, and we get that the radius of the orange circle equals to 30 over 7 units. And if the radius is equal to 30 over 7 units, then the diameter that we are looking for will be twice as large as the radius. That is to say, the diameter d will be equal to 2r. That is to say, it will be equal to 2 times 30, that is 60 over 7 units. Or in terms of numbers, it is equal to 8.514 units. I repeat again, the answer to the question is that the diameter of the orange circle equals to either 60 over 7 units, or in terms of numbers, it equals to 8.5714 units. Okay, so in the next step, I will summarize the lecture. Actually, we wanted to find out the diameter of this orange circle, and the orange circle is located inside a semicircle, and the center of the orange circle is defined as point C. This is point C, and we know that the diameter of the biggest semicircle is equal to 10 plus 20. It is equal to 30 units. The diameter of the small semicircle is equal to 10 units. And the diameter of this semicircle is equal to 20 units. And we want to find out the diameter of the orange circle. We define the center of this semicircle as point X. We define the center of the biggest semicircle as point Y. We define the center of this semicircle as point Z. And we already know that the center of the orange circle is defined as point C. Then we join together the center of the circle that is located at point C with the other centers of the 3 semicircles. So we have here CX, the length of line segment CX, according to the rule that if we have two circles with an external notch between them, that is to say they are touching each other externally, then the distance between their centers will be equal to the sum of the lengths of the radii. In this case, it will be equal to capital R plus small r. While if two circles are touching each other internally, that is to say, like in this drawing, they are touching each other internally at this point. This is the point of tendency. Then the distance between their centers, that is to say, the length of line segment MO, we know that the center of the big circle is point O, the center of the small circle is point M. Therefore, the distance between the centers, that is actually MO, will be equal to the difference between the lengths of the radii. That is to say, OM will be equal to capital R minus small r. Okay? According to the rule that I showed to you, here we have here this semicircle, the length of line segment CX will be equal to, we have here the semicircle and the orange circle that have an external notch between them. Therefore, the distance between their centers will be equal to the sum of the lengths of the radii. And the radius of the small semicircle equals to 5 units. The radius of the orange circle is equal to r. Therefore, the distance between their centers, that is actually line segment XC, will be equal to 5 plus r. So XC or CX equals to 5 plus r. Again, we define the radius of the orange circle as r, small r. Therefore, CX equals to 5 plus r. What is the length of line segment CY? That is actually the distance between the center of the orange circle, that is at point C, and the distance between the center of the biggest semicircle, that it is located at point Y. The center of the biggest semicircle is located at point Y. What are the distance between the centers of the orange circle and the biggest semicircle? That is actually CY. Here, the orange circle and the biggest semicircle have an internal notch between them at this point. That is to say, they are touching each other internally at this point. Therefore, the distance between their centers will be equal to the difference between the lengths of the radii. And the length of the radius of the biggest circle is 15 units, and the length of the radius of the orange circle is equal to small r. Therefore, the difference between the lengths of the radii will be equal to 15 minus r. So CY equals to 15 minus r. And what is the length CZ? C is the center of the orange circle, and Z is the center of this semicircle, that its radius is 10 units. And the orange circle and this semicircle have an external notch between them and this point, that is to say, they are touching each other externally at this point. Whenever you have two circles that are touching each other externally, then the distance between their centers will be equal to the sum of the lengths of the radii. the radius of the orange circle equals to small r. The radius of this semicircle equals to 10. So in conclusion, the sum of the lengths of the radii will be equal to 10 plus r. Okay, so Cz equals to 10 plus r. And what is the value of the length of line segment xy? X is the center of this semicircle with radius 5. Y is the center of the biggest semicircle with radius 15. And the biggest semicircle and this semicircle have an internal knot between them at point A. Whenever we have two circles with an internal knot between them, then the distance between the centers will be equal to the difference between the lengths of the radii. In this case, it will be equal to the radius of the biggest circle, that is 15, minus the radius of the smallest semicircle, that is 5. That is to say, it equals to 15 minus 5, that is 10 units. So we found out that xy equals to 10 units. Then we calculated the value of line segment xz. Again, x is the center of the smallest semicircle, this semicircle, and y and z is the center of this semicircle, and those two semicircles have an external knot between them at point P. That is to say, they are touching each other at point P. Whenever we have two circles with an external knot between them, then the distance between their centers will be equal to the sum of the lengths of the radii. That is to say, it will be equal to the radius of this semicircle, that is 5 units, plus the radius of this semicircle, that is 10 units. That is to say, xz will be equal to 5 plus 10, that is 15. So we found out that xz equals to 15. So after we found out all the values of the line segments in this drawing, we implemented the Pythagoras theorem on triangle XCY. We implemented the law of cosines in triangle XCY. What is the law of cosines? The law of cosines is true in any triangle. Here we have triangle ABC, that could be any triangle. We know that the length of side AB equals to A units, the length of side BC equals to B units, and the length of side AC equals to C units. And the angle between side AB and side BC is theta. Then, according to the law of cosines, C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. And this rule is true in any triangle. You can implement it in any triangle. So we implemented the law of cosines in our triangle CXZ. This is triangle CXZ. We have already found out that CY equals to 15 minus R, CX equals to 5 plus R, and XY equals to 10 units. And this is the angle that we are looking for, the angle between side CX and XY. So, according to the law of cosines, here CY squared will be equal to CX squared plus XY squared minus 2 times CX times XY times cosine theta. Then we substituted CY by 15 minus R, we substituted CX by 5 plus R, we substituted XY by 10, but 10 squared is 100. And we have here 2 times CX, that is actually 5 plus R, and XY, that is 10 times cosine theta. Okay, then we open the brackets on both sides of equation number 1, and we got that 15 minus R squared, it is equal to 15 squared, that is 225, plus R squared minus 2 times 15 times r, that is actually minus 30r, that equals to 5 plus r squared. 5 plus r squared is equal to 5 squared, that is 25, plus r squared, plus 10r, plus 100, and minus 2 times 10 is 20, so minus 2 times 10 is minus 20, so we have here minus 20, 5 plus r cosine theta. Here we have r squared on both sides of the equation, so r squared will get cancelled. And here we have 225 on one side, on this side of the equation, and on the other side of the equation we have 100 plus 25 is 125. So 125 we subtracted from 225 125, and we got here 225 minus 125 is 100, and here we have 100 minus 30r, that equals to 10r minus 20 times 5 plus r cosine theta. Here we subtracted 10r from this equation, and we got that 100 minus 30r minus 10r is minus 40r, so in this side of the equation we have 100 minus 40r, that equals to minus 20, 5 plus r cosine theta. We divided equation number 1 by minus 20 times 5 plus r, and we got that according to equation number 1, cosine theta equals to 100 minus 40r over minus 20 plus 5r. We divided this side of equation number 1, both the numerator and the denominator, by minus 20. So here 100 over minus 20 is minus 5, and minus 40r over minus 20 is 2r, and minus 20 over minus 20 is 1. So here in the denominator we have 5 plus r. So in conclusion we found out that according to equation number 1, 2r minus 5 over 5 plus r equals to cosine theta. Then we implemented the law of cosines on triangle CXZ. So I copied triangle CXZ, and we implemented the law of cosines on this triangle, triangle CXZ. Okay, here we know that Cx is equal to 5 plus r. We already found out that Cx equals to 5 plus r. We have already found out that xz equals to 15, and we already found out that Cz equals to 10 plus r. And this is angle theta, so according to the law of cosines, Cz squared must be equal to Cx squared plus xz squared minus 2 times Cz times minus 2 times Cx times xz times cosine theta. Cz equals to 10 plus r, therefore Cz squared will be equal to 10 plus r squared. Cx is equal to 5 plus r, so Cx squared is 5 plus r squared. Xz is 15, so xz squared will be equal to 15 squared, that is 225, minus 2 times Cx, that is 5 plus r, times xz, that is 15, times cosine theta. Okay? Then we open the brackets. Here 10 plus r squared equals to 10 squared, that is 100, plus r squared plus 20r, that equals to, here we have 25 plus 225 is 250, and here we have 100, so 250 minus 100 is 150, and here we have 20r, we subtracted 10r, so 20R minus 10R is 10R, so we have 10R that equals to 150 minus 30 times 5 plus R cosine theta. Okay? Then we added to this equation 30 times 5 plus R cosine theta, and we subtracted 10R. In conclusion, we found out that 50 times 5 plus R cosine theta equals to 150 minus 10R. Here we divided this equation by 30 plus 5 plus R. And we got that cosine theta equals to 150 minus 10R over 50 times plus 5 plus R. We divided both the numerator and the denominator by 10, and we got that in this equation number 2, 150 over 10 is 15, minus 10R over 10 is minus R, and 30 over 10 is 3. So in conclusion, we got according to equation number 2 that 15 minus R cosine theta according to equation number 2 equals to 15 minus R over 3 plus over 3 times 5 plus R. Then we created equation number 3 that states that cosine theta according to equation number 1 must be equal to cosine theta according to equation number 2. Cosine theta according to equation number 1 is 2R minus 5 over 5 plus R, and it must be equal to cosine theta according to equation number 2, that is actually 15 minus R over 3 times 5 plus R. We multiplied equation number 3 by 5 plus R, and we got that 2R minus 5 equals to 15 minus R over 3. We multiplied equation number 3 by 3, and we found out that 3 times 2R minus 5 equals to 15 minus R. We opened the brackets on this side of equation number 3, and we got that 6R minus 15 equals to 15 minus R. We added R to this equation number 3, and we also added 15 to this equation number 3, and in conclusion we found out that 7R equals to 30. We divided equation number 3 by 7, and we found out that the radius of the orange circle equals to 30 over 7, and if the radius of the orange circle is equal to 30 over 7, then the diameter must be equal twice. It must be twice as large as the radius, that is to say, it will be 60 over 7 units. So we found out that the radius of the orange circle equals to 60 over 7 units, or in terms of numbers, it equals to 8.5714 units. Again, the radius of this, the diameter of this orange circle equals to either 60 over 7 units, or in terms of numbers, it equals to 8.5714 units. Okay, thank you very much.